welcome back to 3 Inquisitive Kids. In this video, we will be covering the discriminant formula, the Pythagorean theorem, many of which you may have already learned. But we will be combining these 3 concepts to solve some interesting problems, a special type of problem that you may not have heard before. So first, what is the discriminant formula? Well, the discriminant formula is b squared minus 4ac is greater or equal to 0. That is the discriminant formula. But then why or how would you use this, you may ask? Well, the discriminant formula allows us to determine if there are 0 solutions, 1 solution, or 2 solutions to a problem that we may be solving. So let me first show you the derivation process of this formula. We start off with ax squared plus bx plus c, and we get 0. A is not equal to 0. And our first step is to try to turn this into a perfect square formula. So we're going to divide a on both sides to get x squared plus b over ax plus c over a equals 0. And now we're going to use our magic wand and try to make some things appear that were not there before. They were hiding from us. X squared plus 2b over 2ax plus b squared over 4a squared minus b squared over 4a squared plus c over a, which equals 0. So let's first pause and see what we did here. We kept this x squared, we kept this c over a. In the middle, we multiplied 2 to the top and bottom of b over ax. And then we also did a plus and minus of the same term. We can factor out this perfect square formula to get x plus b over 2a squared is equal to, after we factor out this, we're going to move this to the right side of the equation. B squared over 4a squared minus c over a. And now we can simplify the right side of the equation a bit more, make them have the same denominator, to get b squared minus 4ac. And because of the non-negativity rule of squares, we know that the value of this entire square cannot be negative. So that's telling us that b squared minus 4ac can't be negative. So it could either be 0 or greater than 0. And that is how we get our discriminant formula. Now that we know what a discriminant formula is, we can go ahead into our first problem. Find the shortest distance between the origin point and the y equals 6 over x graph. Before we do anything, you have to draw this out. Here's our coordinate plane, and here is our graph. What this is asking is we have our origin point, and we have our y equals 6 over x graph. And we're going to try to find a point on here whose distance to the origin point is the shortest. And we're going to try to find that distance. Let's call it lowercase d. So then x squared plus y squared would equal d squared. This is x and this is y. We've made a small right triangle on this graph. Now let's plug in what we know into this equation. We know that y equals 6 over x. So then it would be x squared plus 36 over x squared equals d squared. And now that we see x squared repeating more than once, we can turn x squared be equal to t and let uppercase D represent d squared. So now we get t plus 36 over t equals uppercase D. And now we can go ahead and remove this denominator and multiply t on both sides to get t squared plus 36 equals dt. Then we're going to move all these terms to one side of the equation. We get t squared minus dt plus 36 equals 0. Now what we can do is apply our discriminant formula. From what we just proved, we know that the discriminant formula is b squared minus 4ac is greater or equal to 0. In this case, uppercase D would be our b, d squared minus 4 times 36, which is greater or equal to 0. So then d squared must be greater or equal to 4 times 36. D itself must be 2 times 6, which is 12. And because we know that this uppercase d is equal to lowercase d squared, lowercase d itself will be greater or equal to the square root of 12, which is 2 times the square root of 3. And now we've solved our first problem. The shortest distance between y and the origin point is 2 times the square root of 3. Now we're going to do another problem. This time it's find the shortest distance between the origin point and the y equals 8 over x graph. I want you to pause the video and see if you can solve this problem on your own. Got an answer? Let's check. This time, I will use a different approach to this problem. Again, we're going to start off by drawing out our graph. And this is our function. So this is the origin point, and we're going to center a circle on the origin point. Notice, if the circle is too small, it won't have any solutions with the function, which means it won't have any intersection points with the function. But if we make the circle too big, it will have too many or more than one solution with the y equals 8 over x graph. But if we made the circle just right in size, it will only have, let's only look at this positive half for now, it will only have one solution, 1 point just touching the y equals 8 over x graph. And this point, its distance to the origin point, will be the shortest distance. And because we know that this circle is centered on the origin point, this distance will be r, the circle's radius. So based off of what we know about circles, we can write out our equation. X squared plus y squared equals r squared. That's the function of this circle. And we also know that y equals 8 over x. All we have to do now is go ahead and solve. Again, we can substitute this into this. X squared plus 64 over x squared equals r squared. Let capitalized R equal r squared, and let x squared equal t. So then t plus 64 over t would equal capitalized R. We're going to multiply t on both sides to get t squared plus 64 equals rt. Move all the terms to one side of the equation to get t squared minus rt plus 64 equals 0. Now we can use our discriminant formula. In this case, we have r squared minus 4 times 64 is greater or equal to 0. Let's highlight this because this is a main point, a key point. Now all we have to do is solve for r. R must be greater or equal to the square root of 4 times 64. All I did was skip a few steps. So then capitalized R would be greater or equal to 2 times 8, which is 16. And we know that capitalized R is equal to lowercase r squared. So lowercase r itself will be greater or equal to the arithmetic square root of 16, which is 4. And the reason we use arithmetic square root is because we're calculating for a distance. So distances can't be negative, can be greater or equal to 4. But we're trying to find the shortest distance. So what is the smallest value in this range? Well, the smallest value would be r is equal to 4. So that's why for this problem, our answer is 4. Now, if you want to, you could go ahead and test out some more problems, like what if y equals 3 over x, y equals 5 over x? What would happen, and can you find a pattern to these type of problems? So you never know when you're going to see another problem like this again. Maybe it's on a test, maybe it's in a competition. But there is one expression you can use to solve these type of problems. And the answer is the shortest distance is equal to the square root of 2 times a. In this case, a is y equals a over x. And if you think about it, this makes sense. If we applied this equation to the two problems we just did, in the first problem, our a was 6. So the answer was the square root of 12, which was 2 times the square root of 3. And for our second problem, a was 8. So the square root of 16 would be 4. I hope you learned something from this video, and be sure to come back next time.